Hey, what's up guys? Here we are back again for more of the Python BACnet Stacks Playground. So we're studying BACnet with BACnet networking stacks called BAC0 and BACpipes. Not an advanced networking course, nor is it an advanced low-level bytes on the wire, that would be considered a network programming course where there's other coding languages besides Python like C, C Sharp, C++, Java. Each one of those higher level languages have a BACnet stack. So we're not going deep into the weeds on that. We're just doing Python-based applications that controls technicians would see, or IoT people. Basically with just something HVAC related. Then we're also only in Python, in the Python world, so we're just looking at Python data types, which are nice and simple for beginners to understand, which can also be another advanced topic. In BACnet, there's many data types that the BACnet standard calls for, but in Python it's pretty simple, easy for beginners. Go above and beyond this. We're just doing applied computer science concepts. And then we're still on the vibe code checkpoint 2 with BAC0 for just collecting data with a BACnet read multiple, save data to a CSV file. And then today we're just going to ask ChatGPT to set up a mechanism to rotate the logs every day. And then we'll just repeat these in BACpipes. So BAC0 is, if you remember, it is a wrapper library around BACpipes, which is the BACpipes is just the raw networking stack written in Python for BACnet, and then BAC0 makes things a little bit easier. It's a wrapper library, and then it also has a bunch of bells and whistles that we won't really get into much, but BAC0 does make things easy. So looks like we actually don't have to do that until week 3 and 4. So seems kind of cool. Okay, so let's get into it. This was our file from yesterday that we did. So we've been vibe coding this is our data structures. We've been studying lists and other data structures so far. A list and a dictionary we did yesterday. So this is a dictionary data structure that we are using in our BACnet read multiple. And then also for our CSV file, we're using some features. This is called the datetime library that's built into Python. ChatGPT also added in some try and except handling, which we talked a little bit, where scripts don't error out. So this is basically our CSV column headers for timestamps. A little bit of the CSV file. So this is just appending rows to the CSV file. For every time we redo a BACnet read multiple, this will append rows. This is what it looked like yesterday. So looks kind of cool. What I might do is, So let's just add this to ChatGPT. Go off of this code base, paste it in. Please add in a mechanism when it runs long term that it rotates the CSV files every day, labeled with the date that it rotated the file, and puts that data into a long-term storage directory. Okay. And let's see. So we should say something like the app should handle this long term automatically. Okay, let's see what ChatGPT comes up with for this. So there might be I'm kind of surprised that it didn't even think of another library. There's a couple of different Python libraries that can do these type of things, but it didn't even come up with that. So it's still generating some code. Might as well take a sip of coffee. So it still has the same functions here, which I think we will still get into. That's the way our CSV file works. So this looks like a function here that'll just uses the operating system path, and it joins the log directory, which is another directory constant, and then f strings like we talked about. So this will be the name of the CSV file, and the code will just name that CSV file after the base name and then basically the day. Pretty cool. Alright, so we see if this works. I'll push this code to GitHub too if anyone else is interested in trying it out. Let's see, so this is BACnet 5 code app 2. I'm just tab completing these. The only thing I think we should do is actually put this as its own constant. And we could say something like, okay, so this will be the log directory name, base name. So that'll be the name of our CSV files, and we could say something like my IP address equals that. And then I might actually copy that and then put that down here in our code base. So this is where we pass into back0 our NIC card IP address. So then basically all this code doesn't have to change. The only thing we have to worry about is I just thought of something else too. The only thing we have to worry about is just all these constants that you'd have to just hard code yourself. And then I wonder if we should say something, we'll get into this later in the Python lectures for the CSV file handling, but we should ask ChatGPT, does the CSV file append or create new when script starts? Good question. So what the script does, checks the file. If the script does not exist, it creates it. If the file already exists and has data, it creates new rows. Okay, so we'll get into this later. So it automatically opens the CSV file back up, and then with this little string that says A, that equals append mode. So cool. We'll get into the more deeper into the weeds with the CSV writer in Python later in the theory lectures, but yeah, kind of cool. So it's been writing BACnet logs. This is our new BACnet log, I guess. I'm going to do some testing. I'm just going to delete this and see how the program handles a deleted CSV file. Wait a second, it's actually appending here. So that's why we had 3 scrapes, and then we have 3 scrapes of our made up data. Timestamps look probably okay. Yeah, pretty cool. Okay, I think we should that is working. Maybe I'll still delete it and then just see how the program handles a deleted deleted file. If it crashes, we should add in some more exception handling to do that. So while that's still running, we can go then check to our day 12. Okay, so day 12. Let's get this out of the way. So this is looping over dictionaries. The goal is to iterate through dictionaries using items, keys, and values. By the end of the lesson, you'll be comfortable with looping over key value pairs and processor sensor data and mappings. To loop over key value pairs in a dictionary, it's called items method. Similarly, keys return a view of the keys and values returns the values. Keys and values. Like we talked about yesterday, that's a key and then that's a value. And then the key is immutable, meaning that you can't modify the name of a key, you can always modify the value. To loop over key value pairs in a dictionary, call its items method. Similarly, keys returns a view of the keys and values returns the values. Use a plain for loop to build new dictionaries or filter entries. No comprehensions needed. I think this is pretty self-explanatory once we'll get into this. So like you say for name and value, you could say for key and value in the sensors dictionary, print each key or print each value. So this is an instance using the zip function that I've never used a whole lot. And then that's how to for loop over creating. Alright, so let's copy our mini example. Let's do it. So this handled it well. So remember we deleted our CSV file to do some software testing, and then just to see if the program handled it, which it did, that the CSV file didn't exist, so it had created a new one, and there's no errors. So the script in theory could be good to run long term. Sorry, I'm jumping around a little bit, but like just a little update. When we get all the way through the course in the bonus material, we'll kind of get a little bit into day 39 is like how to deploy the CSV scraper with systemd, which is a Linux service. So maybe we'll get into the little bit of Linux command line, and then this is actually a Linux service on how to deploy long term. So like if your Raspberry Pi or whatever you're running inside the building, if it crashes or if power is booted, if lightning strikes or something, they unplug the Raspberry Pi and plug it back in, this service will automatically restart the program. Docker can also work for this too, but can get a little tricky. So if anyone wants to jump ahead to that, just you can ask ChatGPT, make me a lesson to run it long term on a Pi with systemd, please. So AI will make you a tutorial on how to set it up. So we'll get here a little bit later, but this is getting a little bit into Linux world where you have to do everything through the command line, which Python runs really well at. So don't worry about this now, but if anyone wants to do this now, you can. I prefer Docker a little bit. Docker is a little bit easier to me, but Docker can also be kind of tricky with BACnet. So try both. If anyone's out there and they want to do both, I have a feeling Docker is definitely easier overall, but it might be a little trickier to set up. And then systemd is also another resource for you. Okay, so sorry, we were back here. We were just testing that our CSV file did exception handling. So if this is our script lesson for today, which I just delete out. So I'm just going to shut that off. Control C out of it, and then do Python script lesson. So this is what our dictionaries look like. So this is So this looks like there's a string right here. It puts it inside the dictionary, the curly dictionaries, and then it says for character and text. Wow, so this is actually printing the count of the each character inside here. So if there were, let's just say BACnet SC. See how this little algorithm works here? So it looks like it counted 2 C's because there is a C in SC and one in BACnet. So this little, this is like a little algorithm here where it's kind of, it actually counts the frequency that it sees text. And here, I don't think we have to get into that. That's more getting into advanced topics and algorithms, but you see where it can be used to populate dictionaries. Frequency. Points invert a mapping. So this is calling for a new dictionary for key and value in points.items. So this will be inverse. Oh, so it's just defining a new dictionary. So if we do print, oops. So if we do a print points right here, I might actually just comment you out. So this is our inverse dictionary, which is defined by a new dictionary, and then for key value and points.items, it flip-flops it. So this is kind of something we'll get into a little bit more in algorithms, which would be a really good refresher for me. So this one is build a dictionary of the squares using a loop. Okay, for range, this is would count to 5. This will insert, looks like a square. So that's kind of cool. So it actually defines the key, and then it defines the value right there, which is the square of the number times the number. Pretty neat. So 5, 25, 4, 16, 3, and 9. And then it's all defined on a for loop. Cool. Okay, so let's get into our micro lessons here. Really good exercises for me, trying to I highly recommend trying this stuff on your own too. That's how you get good. Okay, given sensors, temp, humidity, pressure, use a loop to convert temperature to Celsius and store the results in a new dictionary. Ooh, okay, so this one is most similar to I am just going to do, maybe just do this one. Copy. So here is our points. And then the only thing is, like, we don't want to invert. So we could just say this will be points metric, and then we could say maybe we could do if points, what if we could do dot or points get temp. Right, so I just want to try something here. Say a temp point. Okay, so actually I just want to say if the key, if key equals string temp, maybe I'll try this. Okay, so that's key. It's just a K for key. That equals that. Okay, so then we could say then points metric. Our new key will be temp equals, which will be that with our existing value, which is that 70. Here we go. I'm just gonna fat finger this right here. I just want to see if this will work. So this is technically okay, let's just see if this works. Print points metric. Alright, so it looked like that conversion worked. So like what this little bit of code did right here is it's we're looping through each key and value in here, and then if we find a key that equals temp, we're converting, we're grabbing our new blank metric dictionary, defining a new key called temp again, but then see right here, that's V right here, so we're grabbing that value, we're injecting it into here, and then doing our Celsius metric conversion. So let's see, what we should do is I wonder if we could do else points metric K equals V. Okay, so that did it. So that, I think it satisfied our lesson here, is like we created a new dictionary, points metric, and we converted the temperature one to Celsius right here. Else if it's not a temp key, we just grab the old values and stick it into points metric. Cool, glad that went without cheating with AI. All right. Oh boy, so given two lists, names and ages. So names equals a list, square brackets, ages equals a list. Build a dictionary mapping these two using a for loop and zip. Okay, I might cheat a little bit and then just come back here. Where's our zip example? I just don't use zip very much. Here we go. We can just cheat and use this. So names, call this ages. So like sometimes a little bit of cheating here. So create to name, build a new dictionary matching for loop and zip. Just call final. And then we can print our final. Maybe we could even say Bob, Steve, Sally, to pop in some fake names. All right, so that, okay, so what this did is it took two list data structures, and then we have a new blank dictionary, and then what it does is for name in, maybe we should say this, age, not that it matters or anything, but okay, so like what the zip function does is it basically zips all of these values into a new dictionary. It's key, value, key, value, key, value. There can be some instances where, let's say you're scraping BACnet data and you're appending a list, which is an easy value, which is easy data structure to append data to, and then you have another one where you're appending some other feature at the same scrape, and then you want to have some optimize dictionary to look at that data. The zip function can be something that people use, so we got that one out of the way. Given a dictionary mapping devices to instant numbers, invert it with a loop and print its value. Okay, so maybe I shouldn't. So if I go, let's see, what was our invert? We saw an example for this again. I might cheat a little bit and then see the inverse. Oh yeah, that should be easy. Okay, so we do this. I guess like what we could do is just use this. So this will print devices. So this is now our new dictionary populated with data. So if we wanted to invert it, I would say for key value in devices dot items print key value, and I forgot my colon at the end of my for loop. Okay, so that's our key and value, and then we just want to flip-flop them. And then to do this, you have to define a new dictionary, because dictionaries are, the keys are immutable. Devices inverted equals a new dictionary. So what we would do here is devices inverted, the key will be the value, and the value will be the key. Oh, this is good stuff. I haven't done any of this for a long time, so I'm actually kind of enjoying these tutorials here. And so far it's not too hard, but I'm getting kind of worried that it could get kind of hard soon. So here we go. This was inverted dictionary keys and values. And first we defined we defined this, and then we zipped it into the devices, and then we inverted everything. So that was kind of fun. Clean that up a little bit. Write a loop that prints only the dictionary keys whose values are greater than 2. Okay, so maybe we could just do 1, 2, 3. Okay, so we no longer care about the inverted, so I can just get rid of that. So okay, so we can still use our for key and value in devices dot items, and we could say if value is if the value is greater than 2, print value. We could get fancy. How about we put a F string? We can say value was found greater than 2. On curly braces key. Alright, so 3 was found greater on AHU. it's correct. So we could say even inject this, the value. Run that one more time. Okay. And then if you remember the F string, we can inject values into using curly braces. And we're saying we're going to say the value of our injected value was found to be greater than 2 on device. A little bit of English here. So the value of 3 was found to be greater than 2 on device AHU. That makes sense because our AHU was value of 3, nothing else was. So hopefully that makes sense. We iterate through the dictionary keys and values. Then if the value of the value was greater than 2, we just print that, else it doesn't print. So pretty basic stuff, but it's a good refresher to me. I kind of like this stuff. So tomorrow we'll get into sets and tuples. Okay, so this is just more data types in Python. So like under the hood and back pipes and back 0, there's tons of this going on. So like this is like how tons of like network parsing and information flying around on the wire. So this is really good stuff. If you guys haven't had any of this, I highly recommend embracing it a little bit because it's used a lot in the BACnet parsing languages under the hood. So stay tuned and we'll get into this for tomorrow's day 13, sets and tuples. So all right, have a good day guys. Talk to you later.